Hello, my name's Matt Denton, this is Mantis Hacks, and this is part 2 of my XXL giant Lego go-kart build. Good lord, that's heavy. I'm going to need a bigger motor. I'm making a version of this 1980s Lego go-kart kit. Some of this one's missing, I've taken the seat off. Anyway, it's something like that. It's going to be big enough for my nephew to ride, and hopefully me to ride too. And of course I'm going to make it electric powered and add brakes and stuff like that. Well, I had lots of comments and feedback on the previous video, and I very much appreciate that, so please keep it coming. What have we got here? So I'm using glue and metal, yes I am, it doesn't bother me. Lego do the same to hold their large structures together. Of course they use the craggle to glue their Lego bricks, and they quite often use a metal framework. How much weight, how much time? Well, one of these 8 stud Lego Technic beams here would take about 16 hours to print, and it takes just over a kilogram of filament. Are you looking to adopt Would You Be My Dad? Nah. Okay, that's enough of that. Let's get started and take a look at what I've done at the front end here first. So this is a 3-part needle roller thrust washer. So you have 2 outer pieces and then the rollers in the middle there. Obviously I've already got the bearings on the axle here, which is allowing the wheel to rotate nicely. But when I go into a corner, some of these forces are going to be pushing against this surface here. It's going to be pushing these 2 parts together. So that's what the thrust washer is going to be doing. So it sits on there like that. And as those forces push in, it allows the wheel to rotate nicely still. Okay. And originally I was going to hold the wheel in place just using this cap head here and a big washer to stop it from sliding off. But then I thought there's a nicer way of doing this. I printed a slightly different version of this Lego piece here, this Lego Technic bushing, and I've printed a little tiny piece of axle. I get an M8 bolt like this. I've got a hexagon shape in the back of the axle, and the bolt goes down through the axle, and then these 2 parts will get glued together and it will form a cap that screws on the end. I've already prepared one. There it is. So I've pushed the bolt all the way in, and I've added a little cap in the end to hide the bolt, so it looks like a solid piece of plastic. This just screws on the end like that, tightens the wheel into place, and still looks like Lego. I've taken my stud down now. This was poking out originally, and I've also added this piece here which is supporting this whole pedal assembly. An M8 nut recess in one of the pips of this 2x1 plate, so that the nut sits in here and I can screw the studding up from underneath and clamp it all together. So this point here where I've got this 8-way Technic beam, and it's joined together by 2 4-way beams actually making up a complete 8-way beam. I've decided to add 2 bolts that go all the way through to the base. There's a plate underneath now that's basically pulling all of this together, and then to disguise these 2 nuts on the top there, I'm just going to add a piece like that. So now let's take a look at the back end, the brake assembly and the powertrain assembly. My brake disc caliper assembly is bolted onto the chassis through here, and then I'm going to cover these pips up with some little plugs to hide the bolts, and of course I've got to attach the brake cable. Then onto the axle will go my brake disc holder and my brake disc. At the moment this brake disc is a 200mm diameter, which is pretty much the same diameter as the wheel, so that's not going to work. So I need to somehow turn this down to about 170mm. I've borrowed this motor from James Bruton, and he was using this on his bat board, I believe. Now it doesn't feel big enough to me. It's about 2 kilowatts, but based on the weight of the go-kart already, I think I might need something bigger. And this is like a Lego brick, but it's got attachment points for the motor to go into. This is printed in PETG Max so that it will take a higher temperature. I don't know how well this is going to work, but it's worth a go. I don't really like using grub screws down onto motor shafts. It's not ideal. This comes with like a collet and clamp arrangement, and I've managed to print my own pulley wheel and come up with a way of fixing it to here using their clamp. First of all, there's this little collar that I've machined up that could have been printed that just spaces off everything to give it the correct distance from the motor, the Lego housing. This collet goes down inside of the pulley wheel. Just push that down inside of there. 40mm penny washer that goes on first, and then the spacer. Now I've got my collet, and now my pulley wheel with the collet adapter clamp inside of it goes up against that face. My M10 penny washer on that side. This part comes with the kit, but I'm using that just to step down to the size of this bearing, so it's twin bearinged with the belt in the middle, and that's going to help enormously to keep that pulley in place. Start tightening it up. That collet is now clamping down, it's holding onto the pulley. Get that collet nice and tight, so that's clamped down inside now and locked that all to the motor. And what I've done with the large pulley that goes on the axle, and then what I'm using here is actually a Go-Kart 30mm keyway brake disc adapter, and I've just printed my pulley wheel to fit onto their adapter, and it gives a really nice strong fix to that axle through a keyway and these bolts. When the belt is on, with the tension of the belt, it's going to want to pull this motor and the whole shaft around this way towards the axle. So the solution I've come up with is to add this belt tensioner here, 30mm bearing in this end, and then that takes that 10mm bearing that's sat on the other side of the motor shaft there. Put this on here, and it should go over the end of the motor 10mm bearing, and it keeps all of this parallel, so when that belt is tensioned up, it can't pull in too close to that axle. I'll start with the back end first, and then just wind it over the larger pulley wheel. Now there's another little spacer that goes onto the axle. All I need to do is put the rear hub on with the keyway, and then just tighten up this bolt here which stops the hub from sliding off the axle. I'm nearly ready to spin this up and get it moving, but before I do that, I'm going to get these wheels back on, and I'm going to make them fit nicer on the shaft there. I've got a 30mm reamer, it's not quite chuck level. Whiff these out, get them into place, and then hopefully get this motor moving. They are fairly cheap hubs. They're just not tapped terribly straight, I don't think, so the bolt goes in at a little bit of an angle. So I'm just going to run a tap through it, and if that doesn't work, I'll just have to open the holes up a little bit further. That's better. What I have here for the purpose of this test is a VESC speed controller, a 6S battery here. This motor is actually capable of going up to about 50 volts, so it'll take two of these in series, so it should be twice as fast if I want it to be. And then I've just rigged up a little receiver here, and it's going to be running off of my little Spectrum DX7 transmitter. Let's see what happens. It's very nice and quiet and smooth. Some of that. I thought I was going to have to take this down to Quick Fit to get the tyres balanced. Nice. If this has the power, I'd definitely say it's got the speed, so... Before I get carried away, I'm going to make a few modifications. I'm going to move this Technic beam here back by one Lego stud. If I do that, I think this will be an ideal size for my nephew Ruben, because I think the seat will sit somewhere slightly forward of the axle, so it'll bring some of the weight forwards. For me to sit on it and ride it, I think I'm going to make it longer still. What I plan on doing is getting a 12-way Lego Technic beam printed up, and my friend Ivan Miranda in Spain is going to do that for me because he's got a big enough printer. And then the whole go-kart will extend by 4 Lego studs, and then the seat position for me would be slightly forward of the axle, again bringing some of the weight forwards. And I'm also going to modify this axle because right now it's obviously way too long. It sticks out miles on both sides. I have this little tiny lathe behind me here. I thought of a crazy way that I might be able to get this axle into that lathe. I doubt it's going to work, but you know what? I've got nothing else to do, so why not try it? I'm going to mount my axle into the chuck on my little mini lathe, and then at the other end I'm going to support using this bearing in this Lego block, and I'll find a way of setting this height correctly so it lines up with the chuck. I'll clamp it all down, and then I'll try and use the parting off tool to shorten the axle. It's a terrible idea. It's a really bad idea actually, and the bar will probably flail around uncontrollably. But anyway, it'll be fun trying. Just don't try it at home. Using Lego bricks to set this within 1mm of the height of the chuck. That's just lucky. Oh. There's a little bit of wobble there, but it's really not too bad. I think this might work. If you ever find yourself in a position where you have to use a lathe like this, please don't do it. I've got this Technic beam back by 1 position, so it's 1 stud longer now, the whole cart. And I've put more of the bolted sections in, so it's been pinned together. So really I need to get it on the floor now and see if it all feels strong enough. Come on! The back end feels really rigid. If anywhere needs extra strength, it's this point here where these 2 beams are pinned together. There's never going to be my full weight at that point, but I can see it all flexing there if I stand on it. Reinforce this by bolting down through to the plates underneath. But otherwise, it feels pretty good. I mean, you know, no steering whatsoever. Look at that, full lock, and it's going nowhere. It's going to be horrible, isn't it? And that's probably partly due to that lack of differential back here. Yeah, it just wants to go in a straight line. It's going to be terrifying. It doesn't want to go in round corners at all. I'm going to make use of this slippery floor and give the motor a bit of a wind up and see how much torque there is. Well, although there feels like there's quite a bit of power there, it does struggle to get going. I'm definitely going to need more starting torque, so I'm going to look at combating that problem by attacking the motor, the gearing and the battery system all in one go. Well, while I'm waiting for those new parts to come in, I've ordered new batteries and a motor. I decided to tackle the brake system. So what I've done is I've added this brake cable in place here, and I've made up some parts to attach the cable to the pedal and the rear assembly here. I've made it pretty simple. I've just used some hexagonal spacer standoffs, which I've drilled a hole through and then screwed them into the back of these plates and passed the cable through them. I also made my own cable brake adjuster out of an M5 bolt. And this piece here just stops the brake pedal from going too far. I've actually got a modified version of this now, which is a bit better. And of course a spring to return the brake pedal. And there's also a spring already on the caliper at the back, which returns the caliper into position. So that's working really nicely at the moment. I've added potentiometers to both the brake and the accelerator pedal. The reason for that is that when I'm accelerating, I don't want to be pressing the brake and trying to drive the motor at the same time, so the potentiometer on the brake will actually turn off acceleration and also apply electrical braking. The hinge piece here in the Lego has a bolt going through it, and it's an M8 cap bolt. What I've done is printed a small part here which actually goes into the end of the socket head, and it has a grub screw in it that grubs down onto the potentiometer, and then this simple bracket here, and it just so happens that this whole cap head rotates with the pedal as the pedal moves, which then in turn rotates the potentiometer. I've also started writing the code for an Arduino that's going to sit and listen to these two potentiometers and then send a signal back to my VESC controller. I had some parts arrive in the post. First of all, I've got this new motor, which is the censored SK8 or skate version of the aerodrive motor I'm currently using. Now unfortunately I can't fit it because it's bigger than the other version, so I'm going to have to make a special bracket for that before I can test it. It comes with a keyway in the shaft, which is really nice because it means I can get my pulleys machined with a keyway and have them nicely fitted, and then the grubs don't bite down onto the shaft and rotate. So that's really nice. And the other thing I've got is these bad boys. Two 6S batteries, 12 amp hours. And in series, that's going to give me a 12S battery. So twice what I had before, because before I had this little 6S in there. So I'm going to put these two in series, and I've made a little conjigger here which plugs two batteries together into series, but also has a 60 amp blade fuse on it, just in case. If you're wondering why I'm wearing these, it's because when you're dealing with batteries like this that contain so much energy and can release it very quickly if they want to, I feel it's best to wear something, especially when you're this close to them. Even just plugging them in, you get a huge spark, and in fact I need to get an anti-spark switch in here. Right, let's try this. Just start slowly to start with. Make sure everything looks like it's lined up. That seems pretty good. All right, let's give it some beans. Oh my! What in the... That's terrifying. There's no way my sister's going to let my 10-year-old nephew anywhere near this. I don't want to get on it. Wow. Oh God. So I can limit the speed, so I could drop the maximum RPM down but still have all of the power, so it can still deliver all the current it needs to get to that speed, which I might have to do. But I still feel like it would be nicer to try and drop the gearing on this. This is still 4:1 at the moment, but it feels like a 5 or 6:1 would be ideal. I've printed a temporary bracket so that I can mount my other motor, the new motor. This is the one with the sensors in it. The bracket won't stay like this. It'll probably have to be aluminium because at the moment there's way too much flex in it. But at least it's good enough for me to try this motor out and see if it's any better. It's definitely got a smoother start, but still not much torque there to get going. Plenty of terrifying speed there though. Quick test on the floor with the different motor, the censored motor on the back there, just to see if there's any more perceivable torque. Actually, do you know what? That feels like that would actually get going. It's definitely got more go than the sensorless motor. This is running in FOC mode right now. I'm going to try it in BLDC mode, which is a noisier mode, but it might give more torque. I don't know. Change the configuration there. So you can hear the motor whines more in BLDC mode. Actually, that definitely wants to start better. I mean, that feels like that would wind up if I let it go. Well, there you go. Although terrifyingly fast, it's still lacking the torque to really get going. I could go to twin motors. I could have a motor on either side. Or I can drop the gearing down, which I think is probably the best thing to do. Failing that is trying to find a torquier motor, maybe a slower speed, more torque. That's as far as I can go in this video, but I will continue to work on the motor, try and get more power out of that. And I'm going to start work on the seat because it's not going to be long before this is mobile, and I'm definitely going to need a seat for it. Please remember to comment. I really enjoyed the comments on the previous video, and of course, like, share and subscribe.